Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video is about chapter 3 mathematical expectation for the course of SMS 1034. So for these topics, at the end of the topic, so basically you will learn about expected value of a random variable, and then variance and standard deviation, followed by moment, which can be divided into two parts, which is one moment about the origin, which also known as uncorrected moment, and moment about the mean, which is referring to corrected moment. So for this course, we are only focusing on single random variable. Okay, so the first part is expected value of a random variable. By definition, the mathematical expectation of a random variable is known as the expected value. So for this course, it is a mathematical expectation and we are referring to the expected value. So for this case, expected value can be denoted by E and in bracket capital X. Okay, so E here represent expected, X in the bracket here represent random variable, and when we have the small x that represent the value of the random variable. So in expected value, it is actually obtained by summing up the product of the individual value, which is the x of the random variable, and the probability of obtaining that value. And expected value is actually a value of the mean and is denoted as mu. Okay, so Ex is basically mu. Okay, so this is Ex, which is actually mu. Alright, so for expected value, the terms that you need to remember is Ex is mean. Alright, so let's show the next slide. So by definition, if Fx is the value of the probability function of the discrete, so we have here discrete random variable x, then the expected value of the random variable x is as follows. So this is the expected value of a random variable. And if x is a continuous, and if x is a continuous random variable, then the expected value of the random variable x is as follows. So look at the difference between these two. Okay, we can see here discrete and continuous. So discrete we use summation here, and continuous we use integration. So basically the formula is for the discrete one, summation of x multiplied with fx. X small x here represent the value of random variable x. Let me just delete this. Okay, and if you are dealing with the continuous random variable, so in order to find Ex is actually integration of x multiplied with fx dx. What is fx here? Fx is the probability function and is normally given in the question. Okay, so the tips here, the tips that I can give you here is basically, in order to find expected value of a random variable x is basically anything in the bracket here. Anything in the bracket here, you multiply with the function fx. Anything in the bracket here, which is here, you multiply with fx dx. Alright, so that's how you do it basically. Okay, so let's look at the example. Let me just show this here. Alright, so next let's look at the example of this question. So it is another theorem. Before that, we go to this theorem. So the same concept we use here. Okay, the same concept. If fx is the probability function of a discrete random variable, again it is discrete random variable. If it is discrete, then the expected value of the random variable hx is E hx multiplied with summation of hx times fx. Remember, this is discrete, that's why we use summation. And if your x is a continuous, okay, continuous random variable, then the expected value of the random variable hx is integration of hx multiplied with fx dx. So remember that I said just now, the tips here, or the way you try to understand is basically, whenever you try to find the expected value, normally the form of the expected value is e and then something in the bracket. So the tips is anything in the bracket multiply with the function given, which is fx. So look here, previously, as you can see here, ex, and suddenly the formula is you multiply x with fx. Similar for both discrete and continuous. It's just a matter of this one is summation and this one is integration, because one is discrete and another one is continuous. Okay, so if you have ehx here represent expected value of function hx. Mean you are given another function hx and you need to find the expected value of that function. So the keyword is anything in the bracket you multiply with the fx. So here, that's why you say, look here, hx. Okay, anything in the bracket here you multiply with fx. Similar here, hx here you multiply with fx. Okay, so that's the way you do it when you have a single variable for both continuous and discrete random variable. Remember, why you need to find the ex is basically you want to find the mean of that random variable or the mean of that function. Okay. So another theorem is theorem 3.2. For any constant value a and b, ax plus b is equal to aex plus b. AB is a constant. Expected value of a constant, and similar theorem 3.3, expected value of a constant is a constant. For instance, here we have expected value of 10 is actually 10. Expected value of 3 is actually 3. So similar here for this one, you have E, let's say A is 2, okay, X, and then plus your B is 5, for instance. So this one you kind of expand it, it's become E2X plus E5. So basically this one is a constant. That's why constant you can put outside here. So it's become 2EX plus, remember, expected of a constant or mean of a constant is that constant. So this is represent this one. Okay, so AEX plus B, which is actually constant. Any constant you can put outside of the expected value, because it makes you easier to do the calculation. Actually, not necessary to put it outside, but it's good if you can put it outside because it makes your step simpler to find the mean. Okay, and also remember, expected value of a constant is a constant, like this. Okay, let's look at example 3.1. Okay, first of all, when you got this type of question, first thing you need to do is basically you need to set in your mind whether this question is about discrete or is about continuous random variable. For this case, it is a discrete. So keep in mind this is discrete. So when discrete, you need to use summation. Keep in mind that one. Okay, so the question is fx is equal to x over 10 for x 1, 2, 3, 4. So remember, this is discrete. That's why you can use x 1, 2, 3, 4. If they give you the interval x between 1 to 4 inclusive, so the value still x 1, 2, 3, 4. Because you remember or you know that this is a discrete. Alright? Okay, this is a function given fx. So you need to find ex and you have ex. Ex, you need to find hx. So how to find this a? Maybe I can just try to write down here. So for a, so to find x, remember it is discrete. So first thing when it's discrete, you do summation. For x, remember your question x from 1 to 4. And then anything in the bracket, here you put here. Multiply the function given, for this case is x over 10, this one. Okay, so first thing, when you have constant, I would advise for you to put it outside like this. And this is x equal to 4. X times x is x squared. So basically how to do it? You just substitute here. X equal to 1, so 1 square plus 2 square plus 3 square plus 4 square divided by 10. Okay, so basically this one you can just sum up 16 plus 9 plus 4 plus 1. So you got 30 over 10, which is equal to 3. So this is the mean or the expected value of a random variable x. So remember, you are currently dealing with the mean and it is not probability. Okay, mean can be more than 1. Okay, so if you're dealing with the probability, then probability cannot be more than 1 and it cannot be negative. But this is mean, so it mean can be more than 1. Okay, so done for A. So how about B here? The expected value of hx equal to x plus 1. So first thing, similar, keep in mind this is discrete. So your hx here is x plus 1. So remember, previously, you can expand this, become ex plus e1. And you know, expected of a constant is a constant. So you just put it like this, ex plus 1. You know already ex here. So basically, it's just 3 plus 1. So your expected value of hx is actually 4. Okay. So that's for discrete. Let's look at another example, 3.2. The probability density function of a continuous random variable x is given as follows. So the question here asks you to find the expected value and also the expected value of hx. This one for ex. Okay, so keep in mind it is a continuous. I just show you how to do it, but later on you need to do it again because I just show you the step. So for question A, you need to find ex, but remember this is continuous. Obviously you need to integrate. What is the value of x? From 0 to 5. So put here 0 to 5. Okay, remember the keyword, anything in the bracket, which is x here. Anything in the bracket x, multiply with the function given, which is 3x squared plus 3 divided by 170 square. And this is x, so you need to put dx. First of all, I will advise to you again to put outside the constant. So basically, you only need to integrate x times x squared, x cubed, x times 3 is become 3x dx. So this one you need to integrate. So 3 over 170, you integrate x cubed is become x power of 4 divided by 4. You integrate 3x is become 3x squared divided by 2. And you need to substitute from 0 to 5. Okay. So after you substitute, I just shortcut. So you may try it in the middle here. So basically it's become 3, 170. You simplify this. You substitute 5 into x power of 4 and 3x squared. And minus, when you substitute 0 into this, obviously it will be 0. So this one is basically is 775 divided by 4. And you got the answer approximately 3.419. Okay, you may try later, complete the step here. Try substitute this into this and then you got this for ex. And then, how about B? How to find hx, which your hx is x over 3. So first of all, put the constant outside and then you just multiply this one, ex. And you just substitute here, your ex is 3.419. So basically, approximately 3.419 divided by 3 is 1.3, so 13, sorry. Okay, approximately 1.1397. 1397. Okay, so this is the answer. Alright, so as you can see, in order to find the expected value, you need first identify whether the random variable is discrete or continuous. That's the first step. Alright, so let's look next. Next is about variance and standard deviation. So the formula for the variance of a random variable x is basically, we can use this notation, sigma square x, which also can be written as variance x equal to ex minus mu square. And if it is a standard deviation, basically you just square root of the variance, which is sigma x instead of sigma square. Now it is sigma x, and variance x, you need to square root of the variance x, which means you need to square root of ex minus mu square. So this actually can be simplified, and you can get it which is equal to ex square minus ex square. So how to transform from here to here? So let me just show you how actually you can transform from that one to this one, from this one to this one. So first of all, you need to kind of set in mind. Remember at the beginning of the slide, I show you ex actually equal to mu, right? And then, alright, so then in order to show this to this, so basically first of all you need to kind of expand this. Ex minus mu square is actually, so this one we know that ex is actually mu. So how to get this right hand side? So you need to expand that one. This becomes x minus mu. This is square. This one is square. So you just expand this, you will get x square minus 2 mu x plus mu square. Okay, so vice versa, you can change ex to mu, or you can change mu to x, either way. So this one, so I can just simplify, is basically ex square 2 mu ex plus mu square. And this one is actually x square 2. I want to change mu into ex, so it's become ex times ex. And remember, expected our constant, so I treat mu square here is as a constant, so just put it as a mu square. Expected our constant is a constant, so that you got here x square minus 2 ex square plus, and mu square, remember mu is actually ex, so you can just change, it's become ex square. So you simplify these two parts because it have the same unknown here, so it's become ex square minus ex, or mean square. So this is actually variance x. Okay, so this one, right? So this is just to show you from this left hand side to the right hand side. Here, what happened? Okay, right? So remember, for the variance, the formula, this one you need to keep in mind. Variance of x is ex square minus mean square. Okay, ex square minus mean, which is ex square. And for the case of variance, as you can see here, k here is a constant. Okay, when you have for this theorem, when you have variance of 3x, you remember here, this is constant. When you put it outside, it's become 3 square variant of x. Okay, so keep in mind, if expected value, if you put it outside, it just it doesn't change, which means it's 3ex, remember? So, but if it is a variant, whatever constant that you put it outside of this bracket, it becomes squared. So that's why it's actually equal to 9, okay, 9 variance of x. So if you have information on variance of x, so basically you just multiply this with the variance. So that's what it means by this part. Remember, variance of x, kx here mean you have constant k, that's why you put it here k squared. So that's what it means by theorem 3.8, and this is theorem 3.7. Okay, so if later you may look at it again and try it, do it by yourself. Okay. Alright, example 3.3. Find a variant of x for the probability function shown in example 3.1 and example 3.2. So let me just look again on example 3.1. So let's recall first in example 3.1. Let me just divide this into 2. Sorry for the line. And we have example 3.2. Okay, in example 3.1, if you can remember, the fx is actually x over 10 and it is discrete. Okay, so your x is 1, 2, 3, 4, 0 otherwise. And for the 3.2, your fx given is, this one is a continuous and it is 3 x square plus 3 divided by 170 for x from 0 to 5. So this is just recall, okay? So when you do it, you need to look at the slide that I upload in my guru and look at it, it's more clear. Okay, so this is the question, and for this part, they ask you to find the variance. So remember the formula of variance? Okay, variance of x is equal to x square minus mean square. Okay, so this is the formula. So for example 3.1, if you can remember, just now we already do it and we got ex equal to 3, while for example 3.2 we got ex equal to 3.419. Okay, so now in order to find the variance here, so basically we need to find ex. We already know ex, but we don't have ex square, so we need to find ex square. Okay, so in order to find ex square here, remember this one is discrete. 3.1 is discrete, 3.2 is continuous. Okay, so that's keep in mind. So in order to find the variance here, so first thing you need to find is ex square. Remember this is discrete, so you need to use summation for x from 1 to 4. And here, anything in the bracket here, so just put it here. Multiply the function given x over 10. So as usual, put the constant outside. So this become x from 1 to 4 x cubed. Right, so then what happened? You just simplify this. 1 cube plus 2 cube plus 3 cube plus 4. 4 cube. So this one, alright. So when you simplify, 1 cube plus 2 cube plus 3 cube plus 4 cube is basically 100 over 10, which is actually 10. So this is your ex square. Okay, in order to find the variant x square minus mean square. And for this case, we have here ex square 10. Mean we got 3 square. So basically 10 minus 9, which is equal to 1. So this is the variant for function x over 10 for x 1, 2, 3, 4. Okay, so that done for example 3.1. So now looks at example 3.2. So keep in mind it is a continuous. Okay, keep in mind it is a continuous. I'm sorry. Right, so let's look at example 3.2, how to find the variance. Okay, maybe we can just use this color. So again, you have information on ex, so you need to find ex squared, and remember this is continuous, so you need to integrate. So ex squared, because it's continuous, you need to integrate from 0 to 5, anything in the bracket, which is x squared, multiply with the function given here. So function given is 3x squared plus 3 divided by 170, and it is integration, so you have dx here. First of all, put the constant outside so that it's easy for you to calculate. 3 over 170, and you need to integrate x cubed times x squared times x squared, which is x power of 4, plus 3 times x squared, 3x squared, and then you integrate. Okay, so next step, you need to integrate. 170, you integrate x power of 4 is become x power of 5 over 5 plus 3 x square become x power of 3 divided by 3, and from 0 to 5. Okay, so for this part, I want to do it yourself. Substitute this value into this value, and at the end, what is the ex square? You should get 2 to 5 over 17, which is also 13.2353. So this is your ex square, not yet variance. Not yet variance. So this is your ex square. So how to find variance? So this one I want you to do it. So find the variance of x. Okay, I want you to try it by yourself, and maybe we can just discuss this in our WhatsApp group if you have any question. Okay, so that's how you do it. Okay, when you do this topic, mathematical expectation, it's important for you to identify whether it is a discrete or continuous random variable, because it affects the expression, mathematical formulation or expression that will be used to calculate the mean and also the variance. Okay, so next we come to the next part, which is the last part of the chapter 3 about moment. And we have moment about the origin and moment about the mean. So moment about the origin is basically known as uncorrected moment, and moment about the mean is corrected moment. Alright, so first of all, let's look at the notation used. When you talk about moment about the origin, notation is actually mu r prime. This is, remember, this is uncorrected moment. Some book they use this term, so just to make sure you aware of it. Okay, uncorrected moment is actually moment about the origin, and the notation is mu r prime, which actually when you use expectation, remember mean is an expectation, is actually e x power of r. This one. Okay, e x power of r. What happened when r equal to 1? When r equal to 1, ex power of r, your moment about the origin becomes ex. When r equal to 2, what happened to your moment of origin? Your moment of origin become x square. And from here, basically you can already find the variance, which is ex square minus mean square. Alright, the concept is the same. How to find the moment. If they ask you to find EXR, if it is discrete, you use summation. If it is continuous, you use integration. However, what is the differentiate between these two? Is just this notation. How to find it? Similar, anything in the bracket, which is XR, x power of R, multiplied with the function or the probability. Okay, so this is what I mean by this one and this one. Okay, this is about moment about the origin, and we have another term which is moment about the mean. Okay, moment about the mean, what is the difference from moment about the mean and moment about the origin? This one is also known as corrected moment. And the notation, previously we have mu r prime. Here we don't have mu r prime, but we just have mu r. So the notation is mu r, which also can be written as E. Remember, it is corrected moment, and corrected moment means we correct it over mean. That's why we have like this. Okay, so how to find this? If it is discrete, you use summation. Anything in the bracket, which means x minus mu r multiplied with fx. And if it is a continuous, you use integration. Similar, anything in the bracket, x minus mu power of r multiplied with fx. Okay, these notations depend on what type of random variable. That's what is meant by, sorry, this one should be dx here and here. Okay, so that's the third part about moment. And basically, moment about the mean or moment about the origin, we can relate it with the variance and also the expected value. Okay, so first part just now you learn about the expected value. Second part you learn about variance, which also need to use the concept of expected value. And in the part of moment, the third part here also use the both knowledge on how to find expected value and variance. Okay, so this is the one that I showed you just now. Okay, instead of if here for this case, if, okay, if your R equal to 1, so basically your your mu R or mu 2 is actually equal to EX minus mu square. This is if if this is R equal to 2. If R equal to 1, so mu 1 is actually E x minus mu, just like this. And if it's R equal to 3, so your mu 3 is actually E x minus mu power of 3. So that's what is meant by the notation. Previously we have prime, but this one no. That's why this is corrected moment. When corrected moment, we have the distance or from mean, which is mean. Okay, so this one, what is this actually? This is actually moment about the origin. This one is origin. Why? We have this prime, and this one is moment about the mean, which when you write it down is basically E x power of r equal to 2 minus this one mu square. Mu square means this is EX r equal to 1 square, which also can be written as EX square minus mean square. So this theorem will just show you how this moment relate to the concept of expectation and variance. So this is actually a formula of variance when you relate moment of origin and moment about the mean. Okay, so let's look at example 3.4. Okay, example 3.4 is on the probability density function of the continuous. Again, you take note it is continuous. When continuous, you need to use integration. So look at the first question. Find the first uncorrected moment. Second uncorrected moment. So first uncorrected moment mean mu. Let's this one. First uncorrected moment means it is mu prime r equal to 1, and this one is mu prime r equal to 2. Okay, so mu r prime equal to 1 is actually ex, and mu prime r equal to 2 is actually ex squared. Alright, so basically for the first question they ask you to find ex, and the second question they ask you to find ex squared, and the third question they ask you for the variance. So basically variance x is ex squared minus mean ex squared. Alright, so let me just show you how to calculate it. So basically similar to the one that I showed you previously, but this one the only difference is just the notation that I showed you just now on the moment, but then you still need to use the formula for variance, which is ex squared and ex. Alright, for the first question A, just now we know it is ax. So remember, this is continuous. First thing you need to integrate from 1 to 5. Anything in the bracket, which is x, multiply with 5 minus x divided by 8 dx. Okay, I want you to do it. I give you the answer here, and I want you to find it by yourself. You should get 7 over 3 or 2.333. Okay, for question B, they ask you for second uncorrected moment, which is referring to ex squared. Similar, this is continuous, so you need to integrate from 1 to 5. Anything in the bracket, which is x squared, multiply with 5 minus x over 8 dx. So you need to integrate this. Do it by yourself. I give you the answer. Your ex squared or second uncorrected moment should be 19 over 3 or 6.333. So please do it yourself here to make sure you understand. So from here, so basically for question C, variance of x is ex squared minus mean square. So your ex squared is 19 over 3 minus your mean here is 7 over 3 squared. And simplify this, and you got 8 over 9 or 0.8889. Okay, so make sure you try to do it by yourself here. Okay, for example 3.4. Okay, remember the concept. First uncorrected moment is ex power of r equal to 1. Second uncorrected moment is ex r equal to 2. And the third question, the variance of x, is basically ex squared minus ex. Alright. Okay, so I think that is all for this video. So just want you to remember there's 3 things you learn here, and we only focusing on single random variable. Okay, single random variables. Random variable can be in any letter. Most of the time they use x, but if suddenly you saw y or you saw any other letter, so don't be surprised, the concept is the same. Okay, for example, for this task, look at this. The first question, fx means the random variable x. Second question, y means the random variable is y. It's still single random variable. And sometimes you may see any question about z, whatever letter. Okay, so just don't keep in mind that random variable must be x, not necessary. Okay, so it can be x, it can be y, it can be any letter, as long as you understand those letter is represent random variable. And for this course, you only focusing for this chapter we only focusing for single random variable. Okay, so as usual, you learn about expected value and about variance and then about the moment and how it relates with each other. So in order to make sure that you understand it, besides do the one that I asked you in the exercise just now or in the example, as usual you need to do this task. Okay, there is 3 questions here, 1, 2, and the third question is about the moment, which is about the mean, I think, related to the task question 1 and 2. Find the first and second and correct moment and also the variance. Okay, so as usual, please do the 3 tasks. For attendance purposes, please participate. Write down in the comment platform below. Write down your name, your matric number, and group C. Okay, to those who don't have any problem with the link, you may attach your link together with your name. And whenever you've done your task, write down your name, matric number, and group, and give the link. If you have a problem with to submit your link, I will create a platform in My Guru for you to submit all those tasks. Okay, because it's already week 7 and you all still have problem with the link. But make sure to those who submit in My Guru for the task, I only accept PDF file. Okay, only PDF file. No link is allowed in My Guru. So that is easier. Sometimes when you give link, actually the link is empty. So that's not nice. Alright. So whoever submit the task answer in My Guru, make sure you submit in PDF form. Whoever want to just give me the link at the comment below, you can just give me the link. It's okay. Alright. So but for attendance purposes, I will refer to the comment platform below. And make sure you do it. Just write your name, matric number, and group C, and submit your link in the My Guru platform. Okay, I think that's all for this video. Thank you, and all the best. Assalamualaikum.